Hello everyone, welcome back to my YouTube channel, The Chem Classroom. Today I am going to talk about a very interesting topic of chemistry, the symmetry operations and elements. But before understanding the concept of symmetry operations and elements, we must understand what is symmetry. Symmetry is basically defined as the property of a material by which it can be divided into two equal halves. It can be divided into two equal, uh, or I can say that an object is said to be symmetric if it can be divided into two equal halves. So, for example, you can see this figure and this emoji, and we can clearly divide this object or this emoji into two equal halves by cutting it from the middle. Similarly, this is the figure of a bird, and again this bird is also symmetric because we can divide this particular image into two equals are and both the halves are basically mirror images of each other. Therefore, we can say that these two objects, similarly our body is also said to be symmetry. Now, symmetry can be explained with the help of two terms, symmetry operations and symmetry elements. Now, what is a symmetry operation? A symmetry operation is an operation or an action which when performed on a molecule, given molecule, it leaves an indistinguishable and superimposable form of the molecule, which means that a symmetry operation is an action by which if we perform that action on a molecule, we get the same molecule. That we get an indistinguishable form means that we get a molecule which is exactly similar to the original molecule. And these symmetry operations can only be done through different types of symmetry elements. Means a symmetry operation can be performed with the help of a symmetry element only. I think with the help of examples you will be able to understand the concept. For example, the the symmetry elements are axis of rotation, symmetry plane, inversion center, and improper axis. These are the five elements through which different symmetry operations can be performed. Now, the question is which operation can be performed by these elements. So the first element is the identity element. Identity element means that nothing has been done to the molecule, and if we do nothing to a molecule or to an object, we do not disturb an object. For example, if I have this remote, and if I keep it somewhere, and if I am not disturbing it, it remains in its original position. So that is called an identity element. It has nothing to do with the rotation of the molecule. So the, I think with the help of examples, yeah, it will be easier for you to understand the concept. So there are five symmetry elements: identity element, then proper axis, symmetry plane, proper axis of rotation, symmetry plane, inversion center, and improper axis of rotation. The identity element, with the element of identity, what we perform, the operation that can be performed with the help of identity element is identity operation. This operation is also called as identity, and it is represented by a symbol E. Now, the proper axis of rotation, it is the axis through which the molecule can be rotated. So this proper axis of rotation, so with through this axis, what we do is we rotate the molecule. So the operation or the action which can be performed through this element is the rotation of the molecule by an angle of 360 by n, that I'll explain you in the next few slides. And it is represented with a symbol Cn. Then the third element of symmetry is the symmetry plane. Symmetry plane is basically a reflection plane, or I should say it is a plane that divides a molecule into two equal halves, just like this in case just like in case of this just like this object, where with the help of a plane we can divide it into two halves. Similarly, in this image also, with the help of a plane we can divide it into two halves. So basic symmetry plane is the plane. It is all what the operation which can be performed through symmetry plane is the reflection, and A reflection operation means that with the help of a plane, when the two halves are obtained, one half is exactly the reflection of the other half, and it is represented by a symbol sigma. Then inversion center is a point by which if we invert the molecule, the resulting molecule is exactly the same as the original molecule. So it is a point or a center through which we can invert the molecule. It is represented with the symbol I. And the fifth and the last symmetry element is the improper axis of rotations. Improper axis of rotation means rotation followed by reflection. Means improper axis basically combine these two phenomena. Means improper axis combine these two phenomena, the proper axis of rotation followed by symmetry plane. So if we rotate a molecule by some angle, and the resulting molecule is not exactly same as the original molecule, but if we see that molecule in a mirror, the image is exactly same as the original molecule, then we can say that the molecule possesses an improper axis of rotation. However, that molecule does not possess a proper axis of rotation, but it possesses an improper axis of rotation, and it is represented with the symbol Sn. Let us discuss in few more slides what are these different elements and operations in detail. So as I said, identity means when we have not performed any action to the molecule, as in case of for example, uh, when we done nothing to a molecule, it remains in its original position. So in that case we can say that the molecule has an element of identity, and since all molecules remain in their original form, if they are not disturbed, if no action has been performed on them, so we can say that this element of identity, which is represented with an symbol E, is present in all the molecules, in all type of molecules. Whether the molecule is a chiral molecule, means all four groups are different, as in case of this particular example, the molecule shown is CHFClBr. Since it is a chiral molecule, all the groups attached to the carbon are different. Even in this case, if we do not rotate this molecule, if we do not perform any action, any symmetry operation to this molecule, the molecule remains in its original form, and therefore we can say that this molecule possesses an element of symmetry, an element of identity, and all the molecule possess an element of identity. Then comes the proper axis of rotation. So proper axis of rotation is a line which passes through the molecule, and through that line we can obtain after rotation the same molecule. And it may sometimes happen that, for example, we can rotate a molecule by 180 degree, and we obtain an indistinguishable form. Then in that case, if since we are rotating it with 180 degree, the axis will be called as C2 axis. Instead of Cn axis, it is called as C2 axis. Why? Because after rotating the molecule by 180 degree, we have got the same molecule. So what we do is we divide the total angle of 360 degree by 180 degree, and we obtain the 2 as the answer. So this axis, instead of Cn, we call it as C2 axis, because C2 axis means that a molecule, just by rotating it with an angle of 180 degree, it gives a molecule which is in indistinguishable form with the original molecule, which means that by rotating with an angle of 180 degree, we got a molecule which is exactly same as the original molecule. Then, for example, if we have a C3 axis, so for C3 axis, we can, C3 axis means it is an axis by which, it is an axis through which if the molecule is rotated by an angle of 120 degree, we obtain the original molecule. And since we did for C2 axis, again we can do it for C3 axis as well, 360 upon 120 degree, and the answer is 3. So instead of Cn we write here as C3 axis. So C3 axis means by rotating through that axis and an angle of 120 degree, we will obtain a same molecule. Now let us see few examples. Water is a very good example of C2 axis. As I am showing you this molecule with the help of a stick and ball model, this is the structure of water. The red ball is oxygen while it is connected with two hydrogen atoms. Now, what do you mean by C2 axis? I am going to explain you. So C2 axis is the axis that passes through this molecule from top to bottom. If we draw a line, or if we insert a line from the top of this red ball and it passes through it, then with the help of that line, if we rotate it just by 180 degree, still the molecule remains same. Still it contains oxygen in the middle and two hydrogen atoms. Again, if we rotate it by an angle of 120 degree, again the molecule remains same. So just by rotating the molecule with an angle of 180 degree, since we are getting the same structure, so we can say that the water molecule possesses a C2 axis, because just by 180 degree we are rotating and we are getting the same molecule, so it is the C2 axis which is present in the molecule of water. Let us take the other example of ethane. I'll show you the molecule of ethane. This is the molecule of ethane. You can see this is the carbon number 1 where 3 hydrogens are attached, then it is attached to the second carbon, and again we have 3 carbon atoms. Now look at this molecule. Both the carbon atoms are tetrahedral. Clear? Now if we pass a line, or if we pass this pen, or if we pass an axis through these two carbon atoms, and now if we rotate the molecule by 120 degrees, so when we rotate it by 120 degree, again it is the, look, this is the original molecule. If we rotate it by 120 degree, again it is the same molecule. If we rotate it again by an angle of 120 degree, still it is the same molecule, and then third time also it is the same molecule, and we are getting the same molecule just by rotating it through an angle of 180 degree. So it is the C3 axis. Moreover, this ethane molecule also contains some C2 axis as well. The first C2 axis is passing through this line from here, and with the, if we rotate this molecule through this axis by 180 degree, we will get the same molecule. Similarly, a C2 axis is also passing through this. If we rotate it by 180 degree exactly, we will get the same molecule. So there are, in this particular molecule, there are 3 C2 axes which are passing through the molecule, and 1 C3 axis. While in case of water, there is only 1 C2 axis. However, in case of ethane, 1 C3 axis and 3 C2 axis. So since there are two types of axis, we call one of them as principal axis, while the other as secondary axis. So the main axis is the highest, where the value of n is highest. That axis is called as the principal axis. So C3 axis is the principal axis, while C2 axis, they are the secondary axis. This is the main axis in case of ethylene molecule.